This is a help video for the Unit 1 consolidation task, and it's part 2 of that task, which focuses on calculations. So in this help video I'm going to talk through a little bit in general about calculations and then help you to get started on each of the different questions. So in National 5, our calculations so far have focused on the concept of moles. Now, I'm not going to talk in detail about the concept of moles in this video, but I will put some links in the task to some videos which can give you a little bit more of an in-depth understanding of moles. We did talk about them obviously when I introduced the subject, but I have heard a few of you say that you weren't really that confident in knowing really what a mole was. But I'm going to give a brief overview, and then, like I say, I'm going to put a link to some more detailed explanations. So, here's a little overview of moles. So a mole in chemistry is a measurement of quantity of a chemical. So you could say how many moles of water have you got in that cup, or you could say how many moles of carbon are there in this lump of coal. So it's a measurement of quantity of chemical. In terms of that quantity, 1 mole of any substance is equal to the gram formula mass of that substance. So if you calculate the formula mass using the method that we have been taught, and then you put that number in grams, then that will give you the mass of 1 mole. So for example, 1 mole of water weighs 18 grams. So a mole of most substances is not very much. 18 grams of water is probably about a tablespoonful of water. So a mole of any substance is something that you could certainly maybe even hold in your hand, or certainly that you could fit on, say, a small dinner plate. That gives you an idea of how big a mole is. When it comes to moles, as well as knowing that it's a measurement of quantity, you need to know that the symbol for moles is N, and that the unit for moles is MOL. Just MOL on its own. That's the abbreviation, but you could also write moles out in full if you want to. So that's a little bit of an overview of moles. Now we're going to talk about calculations. So when it comes to mole calculations, you have 2 equations that you need to know about. Where do you think you might find these equations if you can't remember them? Hopefully you're saying in the data book, because the data book has all of your important information in chemistry. So 2 equations which I want you to use, which relate to moles, are these ones here. I've underlined the symbol N here. N stands for the number of moles, and we've got 2 equations. N equals CV and N equals M divided by GFM. So remember, the 2 letters together means times, M over GFM means divide M by GFM. So what I'd like you to do now is make sure that you are comfortable with what the symbols in both of these equations mean. So I'd like you to take a little minute, and beside each of these symbols, C, V, M and GFM, I'd like you to write down what that stands for and what units it's measured in. So pause the video now and do that. Right, okay, so hopefully you can remember N in both cases is moles, the number of moles, and the unit is MOL. Okay, taking this one first, C is a measure of concentration, and it is measured in moles per litre. Mole, MOL, L to the power of -1. The little -1 means per, moles per litre, and V is the volume in litres. Looking at this equation here, M is the mass of substance in grams, and GFM is the gram formula mass. In grams per mole. Now, one thing that people got a little bit stuck on in the test was which equation to use, right? And which equation to use if you're asked about moles depends on what information you're given. So our first question in this revision A worksheet is just to get you practicing working out from a number what quantity, what it's actually talking about. So it might be better for me to explain that by looking at the question. So what I'd like you to do, for each of the following quantities, work out whether it is a mass, a number of moles, a concentration, or a volume, you just need to write down the symbol. So you just write down beside each one N, C, V or M. Because when we are using these equations here, which one we use will depend on the information that we're given. So if we are given a mass in the question, then that chances are that's telling us that we're going to need to use this one here, N equals M over GFM. The gram formula mass, the GFM, remember we can always calculate if we know the formula of a compound or if we know the name of an element or compound that we can work out the formula for. However, if we are given a concentration and a volume in the question, then we will need to use N equals CV. So you're looking out for the units. That will tell you what a type of information you're given. One thing to remember though, volume is measured in litres in this equation, but it can also be measured in other units. What other units can you remember for volume? Okay, hopefully you're saying centimetres cubed and maybe even millilitres. So volume, as well as being measured in litres, can be measured in centimetres cubed or millilitres. But if you're using N equals CV, you have to convert these into litres. How do you do that? Hopefully you're remembering to go from centimetres cubed or millilitres. Both of those are exactly the same, by the way. So 1 centimetres cubed equals 1 millilitre. Then you would have to divide by 1000 to convert to litres. Okay, so if you're given a volume in centimetres cubed, you divide by 1000 to convert to litres. A wee example of that would be 500 centimetres cubed equals 500 divided by 1000, which equals 0.5 litres. Okay, so that's just a wee reminder of that. Right. So question 1, we're just deciding what information that we've been given. Okay, 5 grams of carbon. Hopefully you recognise grams. G, that must be a mass. So all I want you to do in your working is write down part I. That would be, not G, that's not what I want you to write down. I want you to write down that's a mass. You could even write it like this, mass is 5 grams. That would be the best way of doing it. Okay. Part 2, it says a 0.2 mole L to the power of minus 1 solution. Now, quite a lot of you in the test got mixed up when you saw mole L to the power of minus 1 and you thought that was moles. Remember, moles is just MOL on its own. If you see MOL with an L to the power of minus 1 after it, moles per litre, that is the concentration of a solution. Okay, so that one, concentration, is 0.2 moles per litre. Okay, try and do the rest of those. I hope you get on okay. In fact, I'll just talk about this last one. 67 kilograms. 67 kilograms. Hopefully you recognise from your knowledge of maths and other things that kilograms is actually also a measure of mass. So in this case, the mass is 57 kilograms. If you want to convert from kilograms to grams, you actually need to times by 1000. And that would therefore be 5000. $57,000 grams. Okay, so pause the video now and do the rest of question 1. Okay, question 1b then is calculate the gram formula mass of each of the following substances. So this should be nice and easy. Remember, one thing to point out is that you need to use the relative atomic masses in the data book to calculate the gram formula mass, and if it's an element, the gram formula mass is just going to be the relative atomic mass of the element, unless it's a diatomic, in which case you'll need to multiply by 2. So I'll just go through the first couple, but if you feel like you're confident, then you can pause the video now and you can try these yourself. Okay, but if you're not totally confident, I'll go through the first couple. So calcium, remember an element, the first thing you want to do is write the formula. And unless this is diatomic, the formula is just the symbol. So for calcium, there's only one calcium, and then we're going to do 1 times the relative atomic mass, which is here, which is 40. And the GFM for calcium is 40 grams per mole. So remember, the GFM is the mass of 1 mole, which is why we can give it the units of grams per mole. Okay, this next one, C3H6. Remember, to work out the GFM, we're just multiplying the number of atoms of that element in a compound by the relative atomic mass of that element. So there's 6 hydrogens here, 6 times the relative atomic mass of hydrogen is 1. So you're doing 6 times 1. And then the relative atomic mass of carbon is 12, and there are 3 carbons. So 3 times 12 is 36. 6 plus 36 gives you 42 grams per mole. Now I'm being a little bit bad here, and I'm not using my calculator. And whenever you're doing GFMs, make sure you use your calculator. So I'm just going to double check that I've actually done that right. I'm fairly confident with 6 times 1, but let's check 12 times 3 plus 6. Now that might seem really easy to you, but it's so common to make mistakes in GFMs, so I really recommend just double checking on your calculator. Okay, part C of this worksheet is then using the N equals M over GFM and the N equals CV equations. Okay, so hopefully you've written this down, because this might help to have this in front of you. Another thing that is worthwhile writing down, something that's worth having if you are doing these questions in an exam or test, might be to write down the triangles, which can help you to rearrange these equations if you need to. So it might be worth you writing these down just now. N equals M over GFM. M is on top in this equation, so M goes on top in the triangle. When we're doing N equals CV, N is on its own in this equation. You do C times V to get N, so C and V must be beside each other in the triangle, and N must be on top. Okay, so it's worth you learning these if this is how you prefer to rearrange these equations. Okay, so for each of these equations, first of all, you need to work out what information you're given, and then you need to work out which equation you need to use and what form you need to use it in. So do you need to rearrange it? I'm just going to go through the first one. So part 1 is calculate the number of moles in 5.6 grams of KOH. Okay, so first of all, what I would be doing is I would be looking at the question and thinking, well, what is that? What information am I given? And what am I asked to find? So I'm asked to calculate the number of moles. So the first thing I might write down in my data column, I'm going to do a data column, so I might write down that I'm looking for the number of moles. The second thing I might write down is that I'm given 5.6 grams. Now 5.6 grams is a mass. Okay, now that I've got a mass, I know that it's the mass equation that I need to use. So the other thing I'm going to have to work out is the GFM. So for KOH, that's going to be 1 times 1, it's going to be 1 times 16, and that's going to be 1 times, and that's the formula for the relative atomic mass of potassium. Potassium is here, so that's 39. And I would always do these in my calculator, even though I think I can probably add them up fine. So that's giving me 56. In a test, always double check these. So there we go, 56 grams per mole, because it's really easy to make mistakes in the GFM. So the GFM is 56 grams per mole. I'm trying to work out n, so I don't need to rearrange that equation, but if I've done the triangle, then I can easily just check n equals m over GFM. I can substitute in my values, so m was 5.6 grams, GFM was 56 grams per mole, and again, doing it in a calculator, even if you think you can do it in your head, so you don't make silly mistakes. So 5.6 divided by 56 is giving us 0.1 mole. So remember, you need to know the units of the different quantities in the equation, so you should know that if you calculate n, it's going to be in mole. Okay, so 56 grams per mole, and the final answer, n equals 0.1 mole for that one. Okay, so I'm hoping that you're going to get on okay with the rest of these. Just to get you started on part 2 of C, it says calculate the number of moles of KOH in 500 centimetres cubed of a 0.5 mole per litre solution. So again, your data column, you're looking for the number of moles. You're given 500 centimetres cubed and you're given 0.5 mole L to the minus 1. That's moles per litre. So what information are you being given there? Well, hopefully you're thinking and you're seeing that what you're being given is a concentration and a volume. Okay, so in part 2, the concentration is 0.5 moles per litre. And the volume is 500 centimetres cubed. Okay, so which equation do we think we're going to use? Well, we're given a concentration and a volume, so of course we're going to need to use this one, n equals CV. And because we're trying to calculate the number of moles, we just do C times V. We don't need to rearrange that equation. So n equals C times V, which equals 0.5 times... Oh, what have I forgotten? I've forgotten something important. Centimetres cubed, I need to convert to litres. So I'm going to divide that by 1,000. Again, use the calculator, no point in making a silly mistake. 500 divided by 1,000 equals 0.5. And I've converted that to litres now, so I'm going to do 0.5 times 0.5 because the volume has to be in litres. And then my answer will be 0.25 mole. Okay, I hope this has helped. Make sure you get on with the rest of those questions, and I'm going to make a separate video for the extension part of this work. Thanks for watching.